Hi everyone, welcome back to another episode. I think this is episode 5 of my NeetCode 150 series. If you are new to the channel, welcome. I'm starting off by solving all 150 of the NeetCode problems without looking at them beforehand. And it's been several years since I did any data structures and algorithm stuff, so I'm basically relearning everything and seeing how much I remember. So just a quick recap. I'm starting off with all the easy problems in all the categories. So I did the first 3 problems of the arrays and hashing category. Then I jumped down to 2 pointers and I completed the valid palindrome problem, though I did struggle a bit with an error in that one. Last video is linked here if you wanna see that struggle. And it looks like we go on to mediums here right away. So I'm going to move on to the next one, which is stack. And yeah, there's an easy one here, valid parentheses. So let's open this up and give it a go. I remember liking the stack data structure, so hopefully I can get through this. Let's see. Given a string S containing just the characters open close parenthesis, brackets, and square brackets, determine if the input string is valid. Okay, an input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, every closed bracket has a corresponding open bracket of the same type. Right. Let's see a few examples. So this is valid, an open and closed normal parenthesis. This one here is valid. It's opening and closing all 3 different types. And this one is not valid because it's opened a normal parenthesis but tried to close it with a square bracket. So that one's false. Any constraints? The string can be quite long, about 10,000 characters, and S will only consist of those 6 characters. Right. So I have an idea already for how I might do this. Let me flip to the whiteboard. Okay, so like I mentioned, I've seen stacks before, and I think I remember seeing problems like this before. So to refresh, a stack is a data structure where when you add elements to it, whatever gets added last comes out first. And what I mean by that is, say you add 1, then 2, then 3. So 3 got added last, but in a stack, when you remove something, you remove from the top first. So the 3 gets removed first, then the 2, then the 1. This is the opposite of the queue, where the first in is the first out, and the last in is the last out. So you add 1, 2, 3. The first thing you're going to take out is the 1, then the 2, then the 3. So we can talk more about queues later once we get to them. But yeah, I recall that stacks are a good data structure for this problem, and I remember doing a problem at some point where all the parentheses were the same type of parenthesis. So parentheses like this. And what you would do, let me make a bigger queue, or sorry, a bigger stack, is whenever you saw an opening parenthesis, you would insert that. And whenever you saw a closing parenthesis, you would remove it. And this would basically work on its own. So we see an opening one, we add. We see another opening one, we add. We see a closing one, so we remove, and we see one more final closing one, so we remove. And then the stack is empty. So in the case where stack is empty, this equals valid. And there's one interesting side case here, right? Because what if I saw a string that started with something that was closed? What do I do in that case? Well, if we look in the stack and it's empty, we know that we can't see a closed. Oh, so basically, right, okay. So now I'm starting to see it. So in the case where the stack is empty and we see a closed, we know there's nothing open because there's nothing in the stack. So this must be invalid. But there's another case where it would be invalid in the context of our problem. So say we add a normal parenthesis, then say we add a square, maybe even a curly, but then say the next closing bracket is a square bracket like this. Well, when we look in our our stack, this is a stack. In our stack, we're looking for a square bracket, but we see a curly is the most recently added. So those aren't equal, so that should also be invalid. So we have those two invalid cases to check for. So let's flip back to the code here and just give it a try and see if I can get this. And I should mention that rather than a stack, I'm basically going to use an array where I remove things from the front of it. I think I can do that with a method called pop, but I'm not entirely sure, and we'll see. We'll see once I get there. Right. So let's initialize a stack, and we'll just make that a normal array. It's a variable called stack. And then we'll go through each character in the string s. And basically, one way I might be able to make this easier is if I make a little thing called open brackets and set that equal to the 3 opening ones. This might be a complete waste of time, and if it is, I apologize, and I'll delete it. And then we could have a close brackets and set it to the opposites. This just might help with my checking and make it a little more clean. So basically, if C is in open brackets, so if the thing that we see first is one of the open brackets, and this is just a cool way of checking if the character is one of these. So if it's one of the open brackets, we simply want to do stack.append, which is adding to the end of the stack. Stack.append whatever the character is. So we just add it to the stack. Then oh, right, I see. I kind of need to know which is which. I might be able to do that later on. I'll explain what I mean in a second. So if it's an open bracket, we just simply append it to the stack. Else, meaning it's a closed bracket. This is where we have to check our two cases. So if the length of the stack is 0, we can return false because we've hit that case I described where we start off with a closing bracket. So in that case, we return false. But then there was another case where we need to check if we're returning false. And that's if we see, for instance, a closing parenthesis, but the most recent thing on the stack is an open bracket. So how would I check that efficiently? Probably I'm going to need an if statement for each thing. So if C is a closing parenthesis, we need to check if, yeah, here's where I need to make sure I'm doing the right thing. So I was thinking stack.pop. Okay, what I might need to do is keep track of the index that I'm at. So the index to insert, and I'm sure there's Python functions that do this for me, but I don't remember them, and I'm trying not to use Stack Overflow if I don't need to. So let me keep track of an index to insert. And once I append something, so stack at index to insert. No, I don't think I like this method. I think I should just try to do it with what I remember. So, sorry, let me just go back to what I had there. Right, so if C is a parenthesis, and if stack dot pop, so what I think pop does is it gives me the most recently added element in the list. But I'm gonna have to check this when I run it. So if stack.pop is equal to, or is not equal to, an opening parenthesis, we can return false. If that's not the case, meaning it is equal to the opening parenthesis, then because I think stack.pop actually removes the element from the array, meaning I don't have to do anything, because I'm either going to pop it off and it's going to be the wrong thing, in which case we return false and just end, or it's going to be the right thing, in which case I do want it to be popped off. Okay. So else if, so yeah, the other two should be exactly the same. So if it is a closing square bracket, we can say if stack.pop does not equal a closing or an opening square bracket, then we return false. And just to make this easier, if it's the closing curly and stack.pop does not equal the opening curly, we return false. If we get through all of this without hitting any errors, we need to check if the length of the stack, if it's not 0, something's gone wrong and we need to return false. Otherwise, we can return true. Okay. So that's an interesting solution. Let me go ahead and run this. Nice. Let's submit. Beautiful. Okay. I'm quite happy with that. I felt like that was a fun solution. At least it was fun for me to write. This brings back memories of stacks, which again, I really enjoyed working with. So my runtime is pretty good. Looks like it beats 75% of everything. And my memory was excellent. I beat 98% of all the other submissions. And I think the reason I didn't do better is because I did save these, but maybe that doesn't matter so much. But I think popping like this, so this did work the way I expected it to. When I say stack.pop, it pops off the most recently added thing and keeps it off. So that worked quite well, and I'm happy with that solution. So thanks for following along, everybody, and I will be back again for question number 6 very soon. Thanks so much.